Today, we're diving into one of the biggest mysteries there is, the human mind. I mean, it's the most complex thing in the known universe. But what if the key to understanding it isn't just about the physical brain? What if it's about the operating system running on that brain? Let's explore the incredible software that makes you, well, you.
I mean, really think about that for a second. You just had a thought. An idea popped into your head. You made a tiny decision, felt a flash of emotion. But have you ever hit pause and just gone, wait, what just happened in there? What process just ran? It all feels so instant, right? Almost like magic. But underneath that seamless experience, there's this incredibly sophisticated operating system hard at work.
And this quote from researcher Joshua Bach, it really gets to the heart of what we're talking about today. It's such a powerful way to think about it. Your brain? That's the hardware. It's the physical stuff, the wetware. But your mind, your consciousness, that feeling of being you can think of that as self-organizing software running on top of it. So how does this software actually work? Well, a leading theory today is that your brain isn't just passively taking in the world. Nope, it's a prediction engine. Let's say you're reaching for your morning coffee. Your brain has already run a simulation. It predicts the weight of the cup, the warmth, the texture. That's a top-down prediction from its model of the world. Then, your hand touches the cup, and your senses send back the real data. If that cup is way hotter than you expected, bam, that's a prediction error. And that error signal comes rushing back up, forcing your brain to update its model. This loop is happening constantly, for everything all day long.
Okay, so let's follow a thought as it makes its way through this whole system. Think of it like a product moving down a cognitive assembly line. And the very first step, the most fundamental one, is that your mind's OS has to build your reality from scratch.
So the very first thing your mind does, and it's doing this right now, is build something called a situation model. This is your brain's best guess about what's going on. It's not just a collection of random data. It's a coherent story. It pulls everything together. Who's doing what to whom, where it's happening, and maybe even why. This is the stage where all of your conscious thinking happens.
And this brings up such a profound point. What you are experiencing as reality isn't raw, unfiltered reality. It's a model. It's a construction. Plato's allegory of the cave just nails this idea perfectly. We're like those prisoners staring at shadows on a cave wall and thinking that's the real world. Our minds are creating those shadows, these mental representations, from the limited signals they receive. In a very real sense, your reality is a virtual one, generated by the OS in your head.
So once we have that working model of reality, where does the actual thinking take place? Let's move on to what you might call the factory floor of the mind. This active space is what we call working memory. Now, don't think of it like a storage closet. It's much more like a mental workbench or a scratch pad. It's the place where you can hold a few pieces of information at once, right now, probably my voice, maybe some of the words on screen, and actually juggle them around, compare them, and work with them. It is the very engine of conscious thought.
But here's the fascinating thing, and it's a huge limitation. Back in the 50s, a psychologist named George Miller discovered that this mental workbench is incredibly small. For most of us, it can only hold about 7 chunks of information at a time, give or take 2. And a chunk could be a single number, a word, or even a whole idea that you're very familiar with. This is a fundamental bottleneck on our thinking power.
So how does an idea get into that limited workspace? This gives us the software view. In a cognitive model called LIDA, the mind is seen as a sea of tiny, specialized software agents called codelets. Each one represents something different, a memory, a feeling, a sound you just heard, and they are all competing constantly for your attention. The winning group gets access to that global workspace, and that's your conscious thought for that moment.
And that abstract software idea has a direct physical parallel in the brain's hardware. It's amazing. At the neural level, it is a literal battle. A group of neurons that represents one thought will start firing like crazy to keep itself active. And at the same time, it uses something called lateral inhibition to actively shut down its neighbors, the competing thoughts. It is a winner-takes-all fight, and what you experience as attention is simply the last neuron cluster left standing. Okay, so we've built a model of reality.
And an idea has won the battle for attention and made it into our conscious workspace. Now what? Well, the mind has to decide what to do. And it turns out we have two very different systems for doing just that.
This framework, which was made famous by Daniel Kahneman, is just so useful for understanding yourself. System 1 is your gut. It's incredibly fast, totally automatic, and intuitive. It's the system that lets you instantly know a friend's face in a crowd. Then you've got System 2. That's your head. It's slow, it's deliberate, and man, it takes effort. That's the system you have to fire up to solve a hard math problem or really think through a big life decision. And the thing is, we're flipping between them all day. And when we're stressed or tired, we tend to lean heavily on the fast but much more error-prone System 1.
And that's the catch. System 1 absolutely loves to take shortcuts to save energy. And those shortcuts create predictable glitches in our thinking that we call cognitive biases. Take confirmation bias, for example. That's our brain's tendency to look for information that proves we're right and just completely ignore anything that suggests we might be wrong. Or anchoring bias, where the first number you hear, say the first price for a used car, gets stuck in your head and colors every judgment you make after that. Our mental software is just riddled with these little bugs.
So why does any of this matter? Because these biases aren't just funny little brain quirks. They're not. They have a massive impact on our lives. They shape how we vote, the things we buy, how we judge other people. They literally shape our perception of reality every single day. Just knowing that they exist is the first, crucial step to making better, more conscious decisions when it really matters.
We have built reality, we've processed it, we've made a decision, but the process doesn't stop there. Here's maybe the most incredible feature of our mental operating system. It can update itself. It learns. So let's put it all together in what's called the learning loop. Every single action you take is based on a prediction of what's going to happen. When the real outcome doesn't match that prediction, you get a prediction error. And that error signal is the most powerful catalyst for learning. It's a wake-up call to the brain that says, hey, your model is wrong, and it forces the brain to adjust its software so that the next prediction is just a little bit better.
And this diagram just shows it all perfectly. You start with your internal representation of the world, your beliefs. That drives an action. When the result of that action creates a prediction error, that error is a signal for learning to happen. This forces you to go back and update your beliefs, constantly making your model of reality more and more accurate. This is the engine of all personal growth, all skill, all adaptation.
So, there you have it. From building a virtual reality from scratch, to processing it on a tiny mental workbench, to deciding what to do with two competing systems, and finally to updating its own code through a constant learning loop. That's the operating system inside your head. It's this incredible self-organizing program running on the hardware of your brain. Which, of course, leaves us with one last really big question to chew on.